Hi, and thanks for watching another video from weldingtipsandtricks.com. Today we're going to talk about stick welding rods and the differences in some of the different types of stick welding rods. Now, someone wrote in and asked about the classifications and what all the numbers meant, and if you want to know about that, click on the link that takes you to the web page. But in this video we're just strictly going to talk about some of the characteristics of each one. We're going to start out with the 6010, and then we're going to talk a little bit about 6011, which is a close cousin to the 6010. And then we'll talk about the 6013, which I don't really like very much. And we will talk about 7018, also called low hydrogen rods, which need to be kept in an oven. And 7024, which is also known as a drag rod. So first, the 6010 is a fast freeze rod. It is used a lot for putting in root passes in pipe welding. And it's fast freeze, so on a root pass, open butt root pass, that's a benefit because you can whip and pause. You can keep a tight arc and then whip and pause, and it lets the puddle solidify momentarily and keeps the puddle from building up too much heat and making too big a keyhole and blowing out. So it's been used for years for pipelines and root passes in pipe, and also just for some general work because it burns through a lot of rust and scale, and it's good for welded over galvanized stuff because it burns through galvanized, kind of volatilizes or vaporizes the zinc coating ahead of it. The 5P is generally considered a smoother running rod than the regular fire brick 6010. Alright, here we have a 7018 3/32 rod, much smoother arc, smoother ripples. When it comes into focus here, you can see a very distinct puddle, a very good delineation between the puddle and slag if you have the heat set right and you have an arc length set right and everything. A tip for you is if you're 100 feet away from your machine, it's good to have a pocket full of 6010 1/8 and 7018 3/32 because you can set the machine on about 90 amps and both of them will run good. So you can put a root pass in with the 6010, and then you can put a smooth pass in with the 7018 3/32 at the same amperage. Alright, here's a 6013. I left the amperage the same. We were set on about 85 amps, which was okay for the 6010 and 7018. Actually, about another 5 would have been good. 90 amps would have been good. For this is cold. It's actually making a decent looking bead, but it's a little too cold. I need at least another 20 amps here to get some arc force going to push that heavy slag, iron powder slag, coating out of the way. Otherwise, I could trap wormholes in it. But that's what I don't like about 6013. But if it's run right, you can do a good job with it. Farmers everywhere swear by them. It's probably what you learn to weld with. Here's an example of what happens if you do it wrong. You can easily get a wormhole bead on each side and slag or nothing down through the middle. And I get people asking me all the time about what's happening with their 6013 welds like this. 7024. Now I cranked the heat up to about 120. That actually was not enough for the 7024. It needed at least 140, and after the fact I looked up the amperage chart, and sure enough 140 was the bottom of the range. Heavy slag coating here. I don't have enough arc force to push it out of the way. I'm using a lot of rod angle, mainly because the camera's in my way, but actually it helped on this to push the slag out of the way. You'll see the finished weld in just a minute. Came out pretty decent, but it wasn't hot enough at all. 6011, left it on 120 amps. This is a 5/32 6011. Heat was actually pretty close for this rod. 6011 rods are a lot like 6010. Very similar. The 6011 was just designed to be run on AC. In fact, it runs better on AC. I left everything on reverse polarity, DC reverse polarity for this little demonstration, and I didn't change the amperage much just to see what happened, but I would have preferred to run this on AC. I'm experiencing a little arc blow. It's wanting to drift toward the bottom, and I'm having to push it up toward the top here, and that's what happens a lot of times when you run a 6011 on DC reverse polarity. But it runs a good bead. I was close enough with the amperage to where I could see it digging in, and it did okay. So after the fact here, there's the 1/8 6010. You can see the distinct ripples every time I move the rod. It makes a distinct freeze line in the puddle, and that's why it's rougher ripples than other rods. Here's a 7018 3/32, run on the same amperage as a 6010 1/8. Nothing to write home about, but just for instructional purposes, you can see the difference in the bead here. And then we have 6013, didn't change the amperage, still set on 85 amps, not quite hot enough. Would have been smoother and better with another 20 amps or so added to that. That was a 1/8 rod, 6013. 6013s run well on AC also. Here's the 6011, 5/32. See, it looks a lot like the 6010. And there's the 7024 drag rod. Even though it wasn't hot enough, seemed cold, and just was laying in there, it still made a good smooth bead, because that's what it's intended to do, is make nice, smooth, big, large welds. But you don't want to weld with it in anything but flat and horizontal right in front of you. Here's another 7024 weld, a little hotter on a lap joint. Don't weld with 7024 overhead, please. You'll wind up with a pant load full of fireballs. Thanks for watching. WeldingTipsandTricks.com.